we no longer consider just yes/no question. Okay, we are able to consider like how well, okay, does a particular factor work, okay, or how large or how small is the effect, because we are able to compare this, consider effect size. So this is much, what should I say, like a much more complete estimation. Okay, it's not just like just give you yes, no, because like NHST, it will just tell you yes or no. Okay, so effect size is just a way to quantify the size of differences between two groups. Okay, so there are, of course, like we could have like a control group and a treatment group. Okay, when comparing groups, people talk about control group and treatment group. Okay, for example, remember the drug testing example I just mentioned. Okay, so normally we have a control group, we have the treatment group. The control group basically like are patients, contains patients who take a placebo. Okay, what is placebo? Placebo is like a something similar to drug, but it's just, for example, just vitamin or something. Okay, it doesn't have any effect, but they will feed this placebo to those patients in the control group. And for the treatment group, okay, the patients in treatment group, they will take the real drug. Okay, the reason for the patients in control group to take the placebo is because like if you do not give them anything, the patients in control group may consider them to be abandoned, and the psychological impact for such a situation could be much bigger than you may imagine. Okay, for human, actually, like the mood. I mean, our mood impact our body. How our body works. Okay, I mean, when you are in good mood, okay, a lot of time your body works much better. Okay, but if you are in a bad mood, for example, you feel like you are abandoned, then your body will come up with something wrong. Okay, so this is like the reason to provide placebo to like patients in the control group is just to make sure, okay, such feeling is not, it's not there, okay, for patients in the control group. I mean, hopefully it's not going to impact their, their body, okay, because we want to see like, how the body react to the drug. So, with or without, okay, we don't want the psychological impact, okay, to play as a factor in this experiment. Okay, so a lot of time, I mean, when we do this experiment, we don't like the person actually like administer the testing. He doesn't even know who take the placebo, who take the real drug. Okay, it is it won't be revealed until the data is collected, and the result is like the analysis result is finalized, and then they will do like they'll review like this type of thing. This is called like a 解盲. Okay, 解盲in Chinese is called 解盲. I don't know the English term for that. Okay, but anyway, because like for past few years, because like we are hit by the COVID-19 pandemic, right? So a lot of countries are trying to develop like drugs for COVID-19. So this type of terms are more commonly seen in a newspaper. Okay, I mean, well, probably it's a good thing, okay, for you guys to understand what that means, okay. So one interesting alternative question will be to ask how good a new drug is compared with the already approved most popular drug to treat that illness. Okay, for example, like since I was talking about COVID-19, so let's just use COVID-19 as an example, because the new drug may be like the 高端, right? 高端. Again, I don't know the English term for that. Okay, it's a new drug developed by Taiwan. Okay, by Taiwanese people, and we know like there are like other drugs such as like what's the name? The one from the AZ, right? I don't know the full name for that. AZ which comes from like British, right? And US also has their drug, right? So those drugs are already approved, okay, and they are popular, okay. And we want to see, you know, our 高端, okay, how good our 高端compared with those like popular drugs, okay, to treat maybe COVID-19. This is a lot of like this a valid question for like medical field. Okay, so in such a case, the control group cannot be a placebo. Okay, it should be the other drug. Okay, so it is not necessary that you have to have control group. It depends on your problem. Okay, some problem may have control group in the sense that, in that case, like the control group basically try to do nothing. Okay, and the other group, like a treatment group, will, you know, you are putting like a, you know, the factor that you want to evaluate to the treatment group. Okay, but in some other type of situation, I mean, there's no control group. Basically, like every group will have a different treatment. Okay, so as an example, okay, imagine you work for a dairy product company that wants to sell overly sugared yogurt to kids. Okay, they will just tell your kids and the mom, tell your dad and mom that this particular yogurt boosts the immune system. Okay, you know immune system, right? So it's like the system that defend like disease, right? So help the kids grow stronger. Okay, so one way to cheat or falsely back up your claim with data is by using milk or even water as a control group instead of another cheaper, less sugary, less marketed yogurt. So the control group selection is important. Okay, if you compare with a group that is not what should I say, reasonable, then this group comparison result is not trustworthy. Okay. So when someone says something is harder, better, faster, stronger, remember to ask what the baseline used for the comparison. Okay. So this is always the case. For you, because in every lab, okay, because you guys, I believe many of you are associated with like a certain lab, right? So no matter which lab you are associated with, you need to work on certain research, and in the research, it is important to come up with a method, okay, which is better, cheaper, stronger, more robust, right? But it is always about what baseline you pick, okay? I mean, if you don't pick a reasonable baseline, your claim is just not trustworthy. It's just false, okay? So there are 3 tools, okay, we can use okay, for group comparisons. Okay, so the first one, this, remember we are talking about the effect size. So effect size is something we can calculate, right? We can calculate. This is kind of like a number, kind of, but not necessarily a number, as I will explain later. But anyway, okay. So how do we, what are the matrix that we can use for effect size? Okay, there are three ways. Okay, so so we must decide which feature, okay, we are going to use for the comparison. Okay, so very common feature is the mean of each group. Okay, so because we are Bayesian, okay, so we'll work to obtain posterior distribution of the differences of means between groups, not just a point estimate of the differences. So to be exact, we have like three tools. The first one, posterior plot with a reference value. Okay, we talked about this earlier already, right? We actually talked about two things. Okay, so for example, like we could have a reference value. We could have a rope. Remember, we could have a rope. Okay, it's a region of like a practical equivalence. Remember? Okay, so so no matter you are talking about like a reference value or rope, basically is similar. That means which are already covered. Okay, the second one is coherence D. Okay, what is coherence D? I will explain shortly. The third one is probability of superiority. Okay, these two are actually correlated in many cases. Okay, yeah. So let's continue. Well, so the first thing we already explained previous, so I will skip. Okay, the second thing, coherence D. Let's take 10 minutes break. When we come back, we will continue from here. Okay.